Buddy, long time no see. I know, it's a long time that I didn't post any video. Okay, and as you see guys, this is me playing Flappy Bird. And okay, obviously I'm a really good player, there is no doubt about it. But I'm really bored playing this game just alone. So I decided to make a challenge with someone as good as me, but I didn't find anyone good like an intelligent virtual player that will play the game in a good manner, right? So this player will be based on self-learning AI. Nevertheless, I'm confident that no one can beat me in this game, guys, okay?
A few moments later.
Oh, damn it, guys. This was a mistake. I can do better, you know that. Anyway, I'm the hacker. Let's forget this, guys, and let's make the AI. But for that, make sure you hit that damn red subscribe button to see more new videos. Let's go. Okay, as in any system, the first thing we try to do is to understand how we can take informations from the system or from the game. So, from this game, and to be able to control properly the bird, we are taking the horizontal distance to know what is the horizontal distance to the next pillar and the vertical distance to the outlet between the two pillars. Okay, so the system or our system here is the Flappy Bird game, and we will control this game using a MIMO controller or multiple input, multiple output controller. And the inputs will be, as I said, horizontal distance to the next pillar and the vertical distance to the outlet plus the bird speed, because in the game that I created, actually, I made this speed variable in order to enhance the complexity of the game with the time. And the outputs will be the fly up and the fly down, okay, in order to control the bird up or down. Actually, this MIMO controller can be made by neural networks or fuzzy controller. The fuzzy controller is a controller that can be made, but we need a really good expertise in the game. You need to know properly the game in order to make a fuzzy controller. But in case of neural networks, you are not needing any expertise. You are just based on some data, okay? And this data will make you the controller that will control the two outputs by using the three inputs in this game. Of course, and each time we need a feedback in order to update the three values and give new updated outputs. So, of course, we are talking about self-learning algorithm, so we will use the neural network as our algorithm or our MIMO controller. And the self-learning model will not be just the neural network, because the neural network will just control the bird, and we will modify the neural network in order to make a good model or a good player. So we need this one who will adapt our neural network. So in this case, we are using GA, genetic algorithm. Okay, model adapter. So as you know, in the genetic algorithm, we need what we call the generation. So generation is many neural networks that are performing at the same time. So we will have many birds flying at the same time, and the one who make a good score, meaning that the one who crossed the long distance, means that he is controlled by the good neural network. Okay, so we will have scores, and those scores we will have also models, and we have a model generator who will take the population. The population is the models, okay, or the members of the generation, and the fitness. So fitness is made through the scores, okay, and through this we will have the selected population and offsprings, okay. The model generator will take the actual models, he will create new models based on selected population, so the selected models with good precision or with good score, and plus some offsprings. We will know what is offspring. Okay, so we have fitness, population. We will pass through selection, okay, based on the score or the distance crossed. After that, we will select some models, population, and after that we will go to the crossover. So crossover mean, for example, we selected 2 or 4 neural networks. 2 neural network will give us a new neural network. Something that we need to put in mind: we will not take the neural network directly as a matrix, but we will make it as a DNA, means a series of 1 and 0, a numerical DNA. Okay, so there's 2 neural networks. For example, we have a DNA of 300, 0 and 1. We will cut it in the middle. We'll take the right side of the first neural network, and the second neural network, for example, we will take the left side, and we will concatenate the 2 parts, which will give it new neural network. Okay, so this new neural network is called offspring. So the total is offsprings plus selected population, and in order to make diversity, we pass through mutation. So mutation is changing some parts of the DNA. So for example, we have 1, we change it to 0, we have 0 to change it to 1, etc. And after that, we will have a muted population. Okay, so now we will talk about numeric DNA creator. So as I said before, this method is created by the generation of neural networks. So we have neural networks, and from these neural networks we'll create new neural networks by using the GA algorithm. And a neural network actually is created by matrices. So we have the matrix that connect the input, for example, to the first layer, and another matrix that connect the first layer to the second layer. Okay, so the GA is something related to DNA, a series of letters, or in this case a series of 1 and 0. So how I could do it is just take, for example, the first matrix and render it as a vector, okay, and the second matrix again as a vector, and then connect all the matrices into one vector, and then code each element of the vector to its binary code. And of course we have to consider a higher precision, because when we restitute the neural network we need to have the same numbers. For example, we have 3.12 value after the comma. When we code it to the binary code and we try to restitute, we need to have, or we need to find the same number. Okay, and to do that, for example, I took as a precision 64-bit, right? And by doing that, we will have a series of numbers 0 and 1, which will help us, of course, to perform all the methods or all the steps that we discussed before, the crossover and the mutation. So for example, for the case of mutation, we will just change some zeros by ones, or just ones by zeros, etc. So this is all about the method, about how we can create a self-learning algorithm through neural networks and the GA. And I hope you understood this well. Okay, so of course I made this from scratch, the neural network from scratch and the GA from scratch. If you want to know how I created the neural network and Flappy Bird, I will just put the link below. I already made videos about that, and I will put the code of the GA. And now let's see the results and see how this algorithm can perform and create a really good player. Damn. He died on 144. He was really doing well. But believe me guys, at the actual configuration of the game, the speed of the bird at this score is really overwhelming. He did the best. I didn't reach that score before in this configuration. Maybe I need to reduce the speed rate. Okay, so this is all guys. You have seen how I could create a self-learning algorithm. You will see below the link of the whole code if you wanna check it for yourself. If you liked my video, just leave me a subscribe and push the like button. See you.